Okay, so we're going to talk about covalent bonds today. Remember, last week we talked about ionic bonds, and in ionic bonds, electrons are transferred from one atom to another. Ionic bonds are between a metal and a non-metal, and covalent bonds are between nonmetals. So it's two or more nonmetals. And in these bonds, electrons are not transferred, they are shared. Each pair of electrons form one shared pair. So there's two types of covalent bonds. We have the polar covalent bond. This is when they share these electrons, but there's an unequal attraction for them. Usually one atom is much larger than the other, and the electrons spend more time around the larger, stronger, more electronegative atom. Water is one of these, and because of its polarity, it has a negative end or side to it and a positive end or side to it. And again, oxygen is significantly larger than hydrogen, so it has more pull on the available electrons in the pair. This also gives it its bent shape. A lot of times when we have nonpolar covalent bonds between three atoms, it's a linear shape, forms more of a line at 180 degrees, but this one is bent due to the slight electronegativity on the oxygen. All right. Then the second one, like I said, is a nonpolar covalent bond, and this is when the electrons are shared equally. What's really important is that polar covalent molecules will dissolve in water. Nonpolar covalent molecules will not dissolve in water. And you can think of oil and water, how they do not mix because oil is nonpolar. All right, so we have Lewis structures, and Lewis structures are a little bit different because instead of showing that the electron is transferred, we show that it's shared. There's three different ways that we draw them. The third way with the dots is what we normally use. It shows all the electrons. But if you look at the very first one where they have the straight line, each straight line will represent one shared pair. And you notice in this particular CH4, carbon is donating 4 electrons to the sharing, and hydrogen is donating 1 each. All right, so the difference between the naming is that we have to actually say how many are in the compound using a root. And these are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, and you probably recognize these from your geometry. And they tell us how many atoms. If the first atom is only 1, we don't have to say mono. That's assumed, but if the first atom in the compound does have more than 1, then we will have to add a prefix to that one. And again, we will still add IDE to the end of the second one. So let's look at it. So we have CO2. So we first identify the elements that are used in the compound, and it's obviously carbon and oxygen. Then we figure out how many we have. We have 1 carbon and we have 2 oxygens. Because the 1 is understood, we don't have to say monocarbon. We can just say carbon, but we have to use the di for the oxygen. So we have carbon dioxide. Take that oxygen and change it to oxide, same as in the ionic. Okay. Okay, now if we have the name, we've got to work backwards. So this one says dinitrogen monoxide. Well, di means 2, so that means I have 2 nitrogens and 1 oxygen. So we'll say nitrogen and oxygen are my 2 elements. I have 2 nitrogens and 1 oxygen. And again, we don't write ones as a subscript. Okay. All right, so here is a practice. So go ahead and pause right now and practice writing these using the table at the top so you can see your different prefixes. You will not have to memorize your prefixes. And then when you're done, you can go to the next slide and check your answers. So go ahead and pause here. Okay, so now that you have worked it out for yourself, look at the answers that we have. We have in the very first one, we have sulfur and chlorine, and we have one sulfur and four chlorines. In example two, we have xenon and oxygen, and we have one xenon and three oxygens. Number three is carbon dioxide, which we've already done. Number four is diphosphorus pentoxide. So that's going to give us two phosphorus and five oxygens. Then we have phosphorus trichloride. So that's going to give us one phosphorus and three chlorines. And then number six is disulfur dichloride. So we're going to have two of both of them. Number five, the L in chlorine should be lowercase. I'll fix that. So looking at the naming, we have N2O3 for number one. So that's going to be dinitrogen trioxide. For the second example, we have P2O5, so that's diphosphorus pentoxide. Again, notice that we dropped the A because we have AO. We don't need that combination. We only need one vowel there. And then we have carbon tetrachloride. That means one carbon and four chlorines. We have one silicone and two oxygens for silicon dioxide, one nitrogen and two oxygens for nitrogen dioxide. And then the next one, we have two nitrogens and four oxygens for dinitrogen tetroxide. Again, dropping that A because of the AO combination. Okay, so take a minute, look at those. Let me know if you have any questions. And you've got some practice problems to do for today, or excuse me, that are due on Thursday. We will not have assignments on Wednesday because of the pre-ACT. So make sure you get those uploaded by 3:35 on Thursday.